capable than a mere batsman or mere bowler, or for that matter, specialist batsman, specialist bowler. Today's world belongs to the all-rounders. You have to be all-rounder to survive. Otherwise, you'll not be able to survive. So many of them globally presume that you cannot do Six Sigma project without already available data. So people do have a lot many myths about Six Sigma that it needs some historical data. Historical data means you already start gathering some data in past and you use that data to deploy Six Sigma. No, that's a big myth, I would say. You don't need to depend on historical or past data. One can deploy Six Sigma project based on my last 19 to 20 years of experience in the industry, in this fraternity of business excellence and optimization and transformation. I can tell you one can deploy Six Sigma project if you don't maintain, even if you don't maintain any past or historical data. Yes, I can agree that if you can have past data, you have an advantage, but it is not mandatory. That's the first myth. Second is, many of them complain that Six Sigma project deployment takes 5 to 6 long months. We cannot spend 5 to 6 long months to solve one problem to deploy Six Sigma, right? So it's not that way. You don't need to spare 5 to 6 long months to solve one problem. One can deploy Six Sigma project in as low as 2.5 months, out of which first 1.5 months is what you have to invest to fix the problem. That is finding the problem, finding the causes, and finally deploying the solutions. And rest of 1 month is to sustain the improvement. So you maximum need to spare 1.5 months, and rest of 1 month is your day-to-day activity of deploying those operational tasks. And you can simultaneously work on 4 to 5 different problems at a time. Hence, if you want to average out time consumption for each problem, that is 1.5 months, which is roughly 45 days divided by say 4 to 5 problems. So 45 days divided by 4 to 5 problems, maximum 2 weeks or 2 to 3 weeks or less than 2 to 3 weeks you got to spare on each problem. And you can also leverage and scale up the lessons learned and benefits across different production lines, different departments, or the locations if those departments face the same problem. So you don't need to spare more than 2 or 3 weeks for a one given problem. And imagine the same problem is also available in other departments or other plans of the organization. You can simply copy and paste the solutions over there. You don't need to deploy those many number of problems. You can scale up the solution deployment. So you can imagine if you're having say 3 to 4 different plans and they're also facing the same issues, and when you're going to deploy the same solutions which you found through the Six Sigma deployment, you can save lots of money and lots of time as well. So that's the benefit. And this particular technique or tool sets or skill sets is not only applicable in our pharma and our healthcare industry, it is applicable across the industry, pan industries, banking, insurance, telecom, retail, IT, and all those industries. And that's the power of these problem solving skill sets. So on that particular note, let's go to the next slide. So very quickly, what is Lean and Six Sigma? Lean focuses on waste elimination, whereas Six Sigma focuses on quality. So I'm going to speak about this in volume. So I'm just going to take you through very quickly. Lean, the goal of Lean is improve process performance through waste elimination and cycle time reduction. And Six Sigma's goal is to reduce the variation, to reduce the defect with the help of prioritization. And of course, in our main program, as I kept on saying, this is just a starter program of 1 hour. In our main program, you have all these skill sets and the tools, how to deploy the tools. You can learn all those things in a stretch for that matter, right? So very quickly, we're just going through it. You can find the details in our main program as well. So Lean and Six Sigma together help to reduce unnecessary operational waste, and at the same time it will help you prioritize the defects, the causes and solutions, and help you deploy it. It will help you, by the end of the day, it will help you to improve the efficiency in organization. At the same time, it will help you to improve quality And once you improve the quality, efficiency, for that matter, it will ultimately help you to improve your customer satisfaction. Once you improve the customer satisfaction, you will get recurring business from the customer. Once you get recurring business from the customer, your company will always be in a profit zone. So that's the power of the skill sets, and that is why companies need these experts. Next slide. Right. So this is the hierarchy of Six Sigma. Since we're talking about Six Sigma green belt, so this is yellow belt, then your green belt, then your black belt, and finally master black belt. So right now we are talking about green belt. In a program, Breath Effects Insight Fellowship Program, we spoke about green belt 2.0. There we are also going to cover up yellow belt related tools and techniques as well. So we are directly jumping to green belt. You can just in our program you can learn green belt best techniques. At the same time, it will also include the techniques for yellow belt as well. So you can directly go and deploy it, because all we want, green belts are what are these individuals? Green belts are the one who lead the projects, and yellow belts are the one who normally are the team members. So all we are focusing on creating the leaders. So we want you to lead the projects, and that is why we're going to train you uh, with the green belt and with the techniques and tools of green belt as well as yellow belt. So once you're done with the green belt and with few years of experience, you can definitely avail black belt and master black belt. So this is what is the hierarchy of this Six Sigma, Six Sigma technique, or Six Sigma, I would say, field of fraternity. So on that note, let's go to next slide. Right. So what is Lean Six Sigma DMAC framework? So let's go through the methodology, very famous methodology of deploying Six Sigma very quickly. So prior to that, let's understand the history of quality and Six Sigma. So these two gentlemen, the W.E. Deming and Joseph Juran, they in fact started work. They started, giving more emphasis on quality, and they took their quality excellence to Japan. And as we all know, these two gentlemen actually introduced quality to Japan. For that matter, these two stalwarts, in fact, for that matter, introduced the importance of quality and excellence to the whole world. So that's about W.E. Deming and Joseph Juran. The concepts were refined through their application in several industries, and these two gentlemen, and then few others as well, they introduced this concept all over the globe, and that's where people started, understanding the value of quality and emphasizing on value of quality. The journey started with the quality, and then came with the Motorola. Motorola, developed Six Sigma in mid 80s for that matter. And from the focus, the pendulum moved from quality to overall business excellence, for that matter, overall process excellence. However, when Motorola started deploying Six Sigma, the focus was more or less on manufacturing business, because Motorola itself is a manufacturing company, right? So it's an electronics company for that matter, right? So Motorola introduced Six Sigma, and post that, General Electricals, is the company. In the mid 1980s, GE made a corporate commitment to apply Six Sigma methods across the companies. GE is not one company; it's an umbrella of different companies. More than 100 subsidiaries are there across different industries, including finance and including your aerospace and all those. So GE is actually a huge giant, and they decided to deploy Six Sigma across the industries. One of the subsidiary of GE is GE Capital. They also deployed Six Sigma. GE Capital is a service based, that's a financial institutions. So prior to GE, people were considering that Six Sigma is more or less for manufacturing companies. In fact, many of them in India also presume that Six Sigma is only for quality, Six Sigma is only for manufacturing. That's the big myth. When I said pharmacovigilance is not a manufacturing thing. Still, a pharmacovigilance need Six Sigma to optimize the performance of the process. That's a service-based activities. So GE was the company, through GE Capital, successfully deployed Six Sigma in a service industry. It's called a service industry. So if you want to pursue your career in, say, TCS and Wipro and all those big IT giants, they deliver the services, right? to the global clients. So it's like outsourcing services, right? So you're going to join those companies if you want to pursue your career into pharmacovigilance and related pharma marketing analytics and related processes, right? So that's the service industry. G Capital communicated or told the whole world, by deploying the Six Sigma in G Capital successfully. They told the whole world that Six Sigma is not only for manufacturing, you can successfully deploy it for a service industry. And when the whole world realized with this illustration of GE Capital, they realized that this is applicable for service industry as well. And that's where ITES, banking, financial services, pharma services, your travel industries, they all started deploying these skill sets of Six Sigma, right? So that's the power of Six Sigma. It's not only for manufacturing, not only for your quality. The pendulum has shifted to the process excellence, to the customer service excellence, and that's where today, more than 70 to 80% of the companies which are utilizing Six Sigma are service-based industries more than a manufacturing industry, right? So that's the power of Six Sigma. So on that note, let's go to the next slide. These are the few of the examples. You can see GE, Coca-Cola, Citigroup, Honeywell, Seagate, Avaya, Ford. These are few of them. There are more than 25,000 companies. If you're aspirant, if you're in India and aspiring to join TCS, Infosys, for that matter, pharma companies, for that matter, even healthcare companies, for that matter, even startup companies, they are utilizing the skill sets, A, to improve the efficiency, B, to improve their services to the customers, and C, to improve their customer satisfaction, and finally, to reduce their operational cost. So there are like more than 25,000 companies globally deployed currently, and they need the expert to who can deploy these skill sets. Now let's go through the Lean Six Sigma DMAC methodology very quickly. Right. So what is DMAC? Define here stands for what is the problem. Measure. So we are going to define the problem in a defined phase. In measure phase, we are going to measure how deep is the problem. In analyze phase, we try to figure out statistically significant causes behind the problem. Once we found significant causes, prioritize. Once we prioritize those causes, if you could remember, we talked about the power of Six Sigma lies into prioritization. So it prioritizes the causes with the help of statistical foundation. That's what we do it in analyze phase. Once we're done with that, then we need to find out the solutions. Improve phase is all about finding the solutions and deploying the solutions, maybe on a smaller scale, to see whether those solutions are working or not. Once those solutions are working, once we validate statistically that the solutions are fixing these causes, then we go ahead and scale up and implement those solutions for a regular basis, on long-term basis. That's what we do it in a control phase. So this is how define, measure, analyze, improve, and control. So let's go through each phase very quickly, one by one. So define phase. So what we do in define phase, we identify the problem in organization. We set the goal to reduce the problem. Of course, when you identify the problem, you want to fix or reduce the problem. That's why, and that's where we got to come up with a goal. And finally, to present what are we going to do into this particular project, we have to come up with the project charter. So let's check a few more tools from the define phase. So in define phase, the tools which we use are like VOC. VOC is a voice of customer. That's one tool. Second is voice of process. Third is critical to quality. These are the different tools we normally use to find out, to identify the problems. And of course, operational level diagnostics is another tool which we're going to train you with in our main course. So these are the tools which help us to understand the problems, identify the problems, and then prioritize the problem. So that's very important. Prioritization. First prioritization is prioritization of problem. That's what we do in the define phase. So this is what is operational lever diagnostics, we call it. So these are the different metrics companies do have, and then we just need to go through few questions. What are different? These are the areas, operational areas companies do follow. These are the metrics. You could see they do have. So how frequently they do maintain the metrics, and for that matter, what is the current performance? Is that current performance is complying with what companies need? So all these things we do in a operational liver diagnostics. So diagnostics, as we all know, is nothing but to find out what is and where is the problem. And once that is done, then we prioritize those problems. So you can imagine, you can see over here, these are like a red thing, these are green thing, so this is where you got to start contributing. So the things which are in a red is where you got to, sorry, the things which are in a green is the areas where you got to work upon quite predominantly, or quite urgently, I would say. So quality management, percentage defective. This is just an example I'm just giving. This is the example of how we establish operational level management in an organization. In detail, you're going to learn all these things in our video on operational level diagnostic. This is just I would say, glimpses of how we normally do it. So this will help us to prioritize the problem. Next thing is project chartering. So what is project chartering? It is a one-pager document which speaks about what is the problem, and then what are the goal, and what are the team members associated, and what's the timeline. So on a very next slide, if you see, this is how the project charter will look alike. So what is the business case? In what area are we working? What is the problem in that particular business case? Then what is the goal we are setting up? And what is the project scope? How much monetary benefits are we speaking about? What are team members associated with this particular project, and the project timeline? Because we're talking about Six Sigma is a project based concept, right? So we have to have a start time and end time, for that matter, right? This is just an example of project charter, how to build that project charter. Of course, we are going to learn through our main course. So that's about the project charter. And finally, process flow chart. Every single company do normally maintain the process flow chart. So in defined phase, it first two things, operational diagnostics and business or project charter, help us to find out what is the problem. Then next tool, process flow chart, is helping us to find out where is the problem. So in define phase, we define what is the problem and where is the problem. So you can see, this is the process map. This is what we normally use it in a define phase to find out where is the problem actually located. So next is the measure phase. Like different things are there. The way we developed project charter, that's in a one page document. This is another one page document which speaks about this is all about converting your problem into measurable unit. So it's like, you have certain target given by the client. So how many times you're meeting that particular target. So what are those non-compliances? What is the zone of non-compliances? So this performance standard define what is the defect and defective, which of course we got to reduce it, and that's why we need that particular outline. So this particular document, which is called a performance standard in a major phase, help us to just come up with the boundaries of the problem. This is the problem, and why this is a problem, because these many numbers of defects are there. So what is a defect? Something which is non-compliant. So what is the target which we need to follow and which we are not following up? So all these things will comprise into your performance standard. And this is, if you ask me, this is the most important document, because around this particular document, the whole project is pivoting. You can imagine that the whole project is revolving around this particular document, because this document defined what is a defect and what we need to achieve. So on the very next slide, root cause analysis. Once we define the defect, the definition of defect and defectives in a performance standard, very next thing is why are those defects? And we need to do it through the root cause analysis. Ishikawa or fishbone diagram is the tool which we use over there. So this is just a glimpse or example of how this Ishikawa or fishbone diagram will look. Then once we are done with that, then next is data collection plan, and then capability analysis is another thing. In data collection plan, DCP is a tool to collect data of causes. Capability analysis. In a capability analysis, we understand whether the process is statistically able to meet a set of client specifications and requirements. So this is about capability analysis. What is capability analysis? How we are going to collect the data, how we are going to use the root cause analysis, how we are going to establish performance standards. All these things we are going to learn in a learn in our main course. This is about the glimpses of what are different activities we are going to carry out in a major phase. This is the example of how we are collecting the data. So this is the data collection sheet you can see over here. Then next is define the capability. Capability is all about finding out where we are standing against client expectations. So how we are going to calculate it in the easiest possible way based on spreadsheet or MS Excel. We are going to tell you that as well. So this is about how we are going to how we are going to calculate Six Sigma value. How we are going to calculate there is one concept called DPMO, defects per million opportunity, or PPM, that is part per millions. So all these things we are going to cover into capability assessment. All these things are available in our Breath Effects YouTube channel. You can, once you start learning it, you can start understanding it. And of course, in our as I mentioned, in our revision models, which is a trainer-based revision model, I'm going to brief you in detail about how to find what is capability and how to find out the capability, how to deploy different tools in Six Sigma phases, a defined phase, major phase, and other phases as well. So that's about major phase, where we measure how deep is the problem, and we also figure out what are different probable causes. I'm not saying significant causes, probable causes. Once we found those probable causes, we cannot work on all the causes. We need to prioritize it, and that's what we do in analyze phase. So with the help of inferential analysis, or with the help of different statistical tests, you know, we are going to prioritize those causes. We are going to find out statistically significant causes. So in analyze phase, we are going to introduce descriptive and inferential statistical test, identification of statistically significant causes, how to identify them. We are going to do that. The different tools which we're going to use are like inferential, for inferential analysis, the testing of hypothesis. What is hypothesis? How we're going to hypothesize it? What are the null hypothesis and alternate hypothesis? What is p value? What is alpha value? We're going to cover those things. Then different statistical test, the chi-square test, 2p test, two sample t test, one way ANOVA. So all different tests, statistical tests, we're going to teach you how to deploy those tool sets. So that's about inferential analysis. This is the chi-square tool, which we built, and as I told you, we also going to share the analytical tool. This is one of those many analytical tools which we're going to share with you. So all you need to do is whatever data you have collected in a major phase, just paste it over here. And here, these are the graphical representations you get, test statistics, and you also get some p-values. Now, what is p-value, alpha value? All things will be covered into your analyze phase, and already there into videos. You can just go through those videos as well. So this is about chi-square testing. Then you have inference, how to infer the chi-square test, and how to conclude the chi-square test. Now, as I kept on saying, why we are deploying the statistical test, because from probable causes we want to find out statistically significant causes, and that's where this chi-square test will help us find out. So that's about chi-square testing example again of how we are going to deploy it into analyze phase. Then we spoke about lean, if you could remember. And in lean, we mentioned that we reduce the process waste. So what are different types of waste associated with lean? So the first one is transportation related waste. Second is inventory related waste. Third is motion related waste. Then waiting related waste, overproduction, overprocessing, defects, knowledge not being used, and misuse of resources. So all these are waste associated with every single process, and as they kept on saying, there are more than 70 to 80% waste are there into each and every process. Thumb rule says that are not your material related waste; these are the process related waste, and these waste are hidden across the process. We need to find it out. In our second certification after Six Sigma, we mentioned that lean digital process transformation, lean agile digital process transformation. Here, we will help you find out those hidden inefficiencies or hidden process waste, how to find them out, how to fix them, all things will be covered step by step into our second certification of Lean Agile Digital Process Transformation. And how we can go, how we can find out different steps for the automation, because nowadays this is a world of automation and you cannot automate every single thing, right? You cannot digitize every single thing. So what are different steps and sub steps, which you need to automate, that will help improve the performance of the process based on the concept of lean. We are going to cover all these things into our lean agile digital process transformation. And the core of that particular concept is identifying this waste. So these are the different waste we are speaking about, and these waste are available in any process across any industry, from manufacturing to IT to healthcare to pharmaceuticals to pharmacovigilance, for that matter, to any industry for that matter. So this is about how to identify the waste. We are going to cover this in detail into our lean session, which we already covered. So you can just go through it and find it out. And once we analyze statistically significant causes, we need to find out the solutions. That's what we do in an improve phase. So in improve phase, we come up with the possible solutions, then generate possible solutions for significant causes identified from analyze phase. We brainstorming techniques for solution finding. So we use brainstorming technique. How we are going to use that technique, we are going to cover it in details in our videos as well. So refining the solutions, pilot implementations, and finally how to validate the solutions, whether which the solutions which are implemented, whether those solutions have fixed the problem or not, whether those solutions have fixed the causes or not. I need to identify, and that identification will come through the statistical validation. So that's what we also do in an improve phase. So very quickly, this is about the example of solution brainstorming. So significant excess. These are different solutions we do come up with. These are the probable solutions, right? We generated this solution through brainstorming, but we cannot work on all the solutions. We got to prioritize it, and that's where we comes up with different techniques. So N by 3 is one technique. Solution prioritization is another technique. We're also going to use solution implementation plan and solution validation based on statistical hypothesis testing. So this is the example of how we are going to refine those solutions. Then this is two proportion validation test. The way we have seen chi-square test in analyze phase, this particular test will help us understand whether the solutions deployed in an improve phase has improved the performance or not. And that's where we compare the performances, how we are going to compare it, what performances we are going to compare, how to deploy this test, how to read this test. All we have already covered into our improve phase. You can just go through it, or of course in our revision sessions we'll just go through it in detail as well. So this is about a two proportion test. So once we improve the solutions for a small scale basis, we have to deploy it for the regular basis, we have to scale up deployment for a long term basis. So in improve phase, we deploy given solution for a shorter period of time. We validate the improvement, and now we are going to deploy it for the longer period of time. So how we are going to do it? That's what we're going to see it in a control phase. So in control phase, we do have a different tools like failure mode and effect analysis. How are we going to use these tool sets? Then control charting is one of the very powerful tool which we use in a control phase. And why are we using it? Control charts help to monitor and control whether process is performing within client specification. And different control charts are IMR chart, X bar chart, U chart, and P chart. And this is a tool which has upper control limit and lower control limit. Now, what is upper control limit and lower control limit? What is the importance and significance of all these things? Then how are we going to validate the result in a control phase? All things we're going to cover in a control phase. And then finally, we need to document few things. So response planning, monitoring planning, and finally project sign off. This is what we're going to do it. This is the sophisticated way of deploying or identifying the problem, then prioritizing the problem, then identifying the causes, then then prioritizing the causes, then identifying the solutions, and then prioritizing the solutions, and then deploying it for the longer period of time or scaling up the deployment, and that too based on statistical foundation. This is what we normally do in Six Sigma project deployment. So that's about Six Sigma projects. This is a monitoring plan, which we need to showcase. So this is what a monitoring plan will look. What are different components of monitoring plan? Of course, we are going to go through those videos. You can check it out. And this is what we do how. So as I kept on, repeating, this is just a summary of what we normally do in a, Six Sigma DMAC deployment. In define phase, we diagnose the problem. Then once we diagnose it, we quantify the problem and set the improvement goal through project charter. Then we check where is the problem located in the process with the help of high level process map. Then we define how are we going to measure the problem with the help of performance standard document. Then we are going to list out probable causes which lead to the problem with the help of fishbone or Ishikawa diagram. Then we are going to select critical causes from probable causes with the help of CI matrix. Then we are going to collect data for the project Y and these critical causes with the help of major phase data collection. Once that is done, we are going to find out how deep is the problem with capability analysis. We spoke about DPMO or PPM or Six Sigma value. This is what we're going to cover over here. Once we are done with the major phase, we need to statistically prioritize significant few causes from critical many causes. That's what we do with the chi-square test and goodness of fit. These are different testing graphical analysis. Then in improve phase, once we found the significant causes over here, we got to fix them. And to fix them, we got to come up with the solutions. The list of probable solutions we do through the brainstorming. Then select potential solution from list of probable solutions, that is with the help of solution refinement. These are the tools which we are going to use. Imagine how many tools are there for deploying these different steps. And these are the steps by the way. We implement the solution. Then test solutions by implementing them on a short-term basis. So on a short-term basis, we are going to implement the solutions through pilot deployment. Once we deployed it for a short-term basis, we again collect the data. Then post collecting the data, pre-improvement phase and post-improvement phase, we are going to compare it together through a 2P test, that is two proportion test. We have already seen how the two proportion test looks like. Once that is done, we confirm whether the problem is reduced or fixed with the help of capability analysis. We'll update our process map. That's what we do in an improve phase. And finally, in control phase, we develop control plan to monitor project Y for long-term basis with the help of control plan, monitoring plan, and response plan. We'll collect the data of Y, project Y, that is our problem. Then we check whether project Y is under control or not with the help of control chart, that is P chart. Then again, we'll use two proportion tests to compare whether performance in control phase has sustained or not with the help of statistical testing. Then with the help of capability assessment and control charting, we try and see whether the performance of the given project Y or given problem is under control or not. So this is what we are going to do in the control phase, and this is what we normally do in a define, measure, analyze, improve, and control. That is DMAC methodology of Six Sigma. So I guess on that particular note, this is what we are done with the today's session. This is the foundation session, and the purpose of foundation session was to just introduce you with the concept of Six Sigma, its importance, how it is going to be beneficial to you. Then going through what is lean, what is Six Sigma, and the DMAC methodology, all we have covered. The purpose of this session was to create the interest in you. If you find this particular skill sets of lean, Six Sigma, and process optimization will be valuable to you, please join BreathFX family, and please join the YouTube channel and start learning those skill sets. And as I kept on saying, 2 months is a timeline you should keep for yourself. Learn those, get some simulated internship projects which are going to provide to you. deploy those projects and get entered into the market. I'm very much sure if you want to seek the job, a, B, if you want to pursue your higher education globally, and C, if you're working in any organization and want to grow in that organization, these three globally acclaimed, recognized, and accredited certification will add a huge value into your profile. So I guess on that particular note, thank you so very much for your time for attending this particular session. And this is what the final thing. Uttishta Bharata, Ma Bharati shall rise again in her full glory. I'd like to welcome you all to the Breath of X family under the center which we have developed in association with Modern College of Pharmacy Nigri, and we look forward for your joining in our particular family. So on that note, thank you so very much and have a wonderful career ahead. God bless you all. Thanks a lot. Hello, ma'am. I guess we are done with the session.